Okay, so new chapter. This is 4.1, and we are going to begin a big chapter here, writing equations in slope-intercept form. So we've been working with slope-intercept form. Now we are going to write equations in slope-intercept form. And we're going to do that by certainly using our slope-intercept formula. Y equals mx plus b. As we recall, m is my slope, b is my y-intercept. So you'll hear me over and over and over tell you, when you're asked to write an equation of a line in slope-intercept form, there are two things we're always going to be looking to find. We're going to be looking to find slope, and we're going to be looking to find y-intercept. If I know those two things, I can certainly write an equation in slope-intercept form. These are the easiest questions on the quiz and the test, and in both my classes every year, people miss them. Don't overthink it. Write the equation in slope-intercept form. So we're going to write the equation in slope-intercept form, which means you certainly want that sucker to look like y equals mx plus b. Given the following information, I will say letter A. I will say you have a slope that's equal to -3 and a y-intercept is equal to 1/2. Letter B, I will say a slope of 0, a y-intercept of -2. If you are given the slope and you are given the y-intercept, it's as easy as it gets. We just simply rewrite the equation, substituting in what I know. So what I have here is y would equal my slope, which is m, -3. My y-intercept is 1/2 plus 1/2. That's all I got to do. M is my slope, B is my y-intercept. I substitute them in to slope-intercept form, and I have the equation. You have a slope, you have a B, y equals 0x minus 2. That would go away because 0 times anything is 0. Y is equal to -2. And hopefully you were able to tell me that because the slope was 0, you had a horizontal line going through -2 on the y-axis. So we're going to start to piece this stuff together that we've been building on. That's the easiest way to do it when it's given, but we're not going to be given slope, and in 4.2 we're not going to be given y-intercept. So let's look at letter C. I'm going to make a little xy coordinate plane here. Okay. So here's my graph. I'm going to label some points on here. I've got 0, -3, and I have the ordered pair 4, 3. And this is given to you in the problem. It would be, the problem will present itself. Here's this line. Here's these points that lie on the line. What is the equation of that line in slope-intercept form? You need two things to write an equation of a line in slope-intercept form. You need slope and you need y-intercept. I am going to find my slope. And when I'm given a graph, I can certainly do rise over run. I would do change in y over change in x next, but my rise, if I go from -3 up to 3, you are going up 6. 1, 2, 3, 4, 5, 6. And then a run of, if you are going from 0, but now you're over to 4 on the x, that's a run of 4. Your rise of 6, a run of 4. Change in y over change in x. I like using the graph when I know I can get my rise over my run. My slope is positive, and it is a rise of 6, a run of 4, which reduces to 3/2. You can certainly get it that way. Or I could also do change in y over change in x, because I don't necessarily have to have the graph to get it. You've got points that lie on this line. Remember, we are going back, and I'm going to go this. You have the ordered pair 4, 3, and you have the ordered pair 0, -3. Change in y over change in x. When we are finding slope, first step I said, circle your y's. There's my y's. The change is the subtraction of them. Go left to right. 3 minus a -3 over 4 minus 0, minus minus, slash slash, 6/4, and I still get 3/2. Get the same thing, whether I count rise over run or change in y over change in x. I have one piece of the puzzle. I have my slope. I just did it two different ways. I need my b, where it crosses the y-axis. Right here. In today's lesson, I want us to start paying attention to x will be 0. We should remember this from 3-5. Whenever I have an x of 0, I know my y-intercept. So my b is going to be that -3 right there because it's where it crosses the y-axis. But I also, if I wasn't given this graph and just given these points and said they lie on a line, I know that's my y-intercept regardless because my x is 0, and I know that every y-intercept has an x of 0. You now have the two pieces of the puzzle you need to write your equations. You have an m of 3/2 minus 3. And you could certainly check this. If I said to graph this, you would say, well, I need to plot my y-intercept, which is -3, and then I have a rise of 3, 1, 2, 3, a run of 2, a rise of 3, 1, 2, 3, a run of 2, 1, 2. And I certainly get that. We're going to be given the graph, we're going to be writing the equation. Letter D. I'll make another little XY coordinate plane here. We'll get a graph on there. Okay, there's another line. I will tell you this point right here lies on that line, the ordered pair 0, 2. And this point 4, -1, also lies on that line. Write the equation. Go ahead, pause the video, take a second, and find out. All right, let's take a look at it. Two things you need to write. You need a slope, you need a y-intercept. Certainly, I hope you can tell now, when this x is 0, I've got my b. I need to find the slope of this line. I'm going to start out this way this time, and I am just going to do change in y over change in x. First, no reason. I'm going to do it two different ways. I will circle my y's, and I will go 2 minus a minus 1, and I will go 0 minus 4, minus minus slash slash, 3 over -4, or I have a -3/4 as a slope. And if I were to do rise over run, I certainly see that the slope of this line is negative, it's falling. To get from point to point, to get from here to here, my rise, 1, 2, 3, down 3 to the right, 1, 2, 3, 4. And there's my rise over my run, -3/4. Down 3 over 4. Now remember, you can also go this way, and you're going to get the exact same slope. Because now, though, I'm going up 3, and I'm going to the left 4. So I still get that -3/4. You've got your y-intercept because your b is equal to 2, because your x is 0. Write your equation. Y is equal to -3/4 x plus 2. And again, go back to y equals mx plus b and graph this. If you were given this equation and said graph it, you could certainly plot 2. Your next point would be a rise of 3, a run of 4, rise of -3, 1, 2, 3, 1, 2, 3, 4. And it gives me that point right there. You're not always going to be given the graph. I am going to say the line passes through the following points. And we're going to do a couple where I just give you the points. So letter E here, instead of graphing it, because I certainly don't want to graph it if I don't have to. If I just want to write the equation without graphing, all I need are these points. And for this to tell me that the line passes through it, that these points lie on the line, because if I have 2 points that lie in a line, I certainly know how to find the slope, and I know that I have my y-intercept because it is telling me my x is 0. I know my b because x is 0. I got to find my m, or my slope. Now, I definitely don't want to graph this and do rise over run. I'm definitely going to do change in y over change in x, just like we did with finding slope. I'm going to circle my y's. 5 minus a minus 1 divided by -3 minus 0. Minus minus slash slash 6 over -3 gives me a m, or a slope of -2. I know what b is because x is 0. I'm going to write my equation. Y is equal to my m. -2x subtract 1, and I got it. Let's do one more. I'm going to look at letter F. I'm going to say 0, -5, 8, -5. And again, these points lie on the line. Hopefully you're picking up what I'm throwing down now. I'm looking at this. These points lie on the line. My x is 0, so I know what my y-intercept is. My y-intercept is going to be a -5. And hopefully you're seeing something right now that's happening. My y values are both -5. So what's going to happen when I subtract -5 from -5 and I do change in y? What if I subtract 2 from 2? It's going to be 0, isn't it? And my y is staying the same. This is the line y is equal to -5. If you didn't see that right away, that's okay. Just do change in y over change in x. I'm going to circle them. And then you may notice, I have -5 minus a -5 over 0 minus 8. I don't really care what that is because I know that's slash 0 over -8. I have a slope of 0. Please do not write this equation 0x minus 5. You're never going to see that. That goes away always. We don't write 0 times anything. Let's get rid of it. Y is equal to -5. There's the equation of the line. But it really, that 0's there. It's a horizontal line. Y equals -5. Horizontal line going through -5 on the y-axis. And I know that horizontal lines have a slope of 0. And that's why that mx goes away, because when my slope is 0, 0 times anything is 0. The last thing we need to talk about a little bit is when you see these in function notation. And nothing's going to change. Nothing is going to change. Just like when we graphed functions y equals mx plus b, I could say f of x is equal to mx plus b. We're just going to write it a little differently. If I have f of 0 is equal to 10, and let's say I have f of 6 is equal to 34, and I want to know what is this function that has these inputs and outputs. We just go back to what we did in chapter 3 with our definition of what functions are and what this really means. This is a relation. This is an xy ordered pair. I'm plugging 0 in for x, and I'm getting 10 out. Function evaluated at 0 is 10. You have this xy ordered pair. You have 0, 10. Function evaluated at 6. When I plug 6 in for x, it tells me my y is 34. I have the ordered pair 6, 34. When you're given something in function notation, just write it as ordered pairs. But when it's given in function notation, I'm going to report back my equation in function notation as well, but that's really easy to do. You need two things to write the equation of a line. You need slope and you need y-intercept. You can see that this x is 0, which tells me my y-intercept. I just need to find slope. And I'm going to do that by changing y over changing x. I'm going to circle my y's. And I'm going to go 10. That 10 right there, subtract 34, divided by 0, subtract 6. 10 minus 34 gives me a -24. 0 minus 6 gives me a -6. -24 divided by a -6 is a +4. There's one piece of the puzzle. I got my m is equal to 4. Second piece, my b is definitely equal to 10 because my x is 0. I can now write my function. I will say f of x is equal to 4x plus 10. And remember, you could always check this. If f was 0, I should get 10. Well, what's 4 times 0? 0 plus 10 would give me 10. What if this x was 6? 4 times 6. 24 plus 10 gives me 34. Give it back in function notation though. If you said this is y is equal to 4x plus 10, I'm certainly not going to mark that wrong. But when I'm given the problem in function notation, let's report back in function notation. Give these problems a whirl.